You have completed a 3-station investigation of the properties of gases. What did your investigation of gas properties show you? You did 3 things. You took a closed volume of air in a syringe and you took it from cold water to hot water. You took a volume of air trapped in a glass bottle with a 10-cent valve and watched it as you warmed up the air. And you watched a marshmallow inside a syringe as you pulled out on it and decreased the pressure around and therefore inside the marshmallow. Let's talk about the first one. What happened to the plunger when you took it from cold water and put it in hot water? The plunger came out a little bit. The gas then actually expanded. Why is that happening whenever the gas warms up? Well, you may recall that temperature is a measure of kinetic energy, energy of motion. And as the temperature increases, the energy of motion increases. So, what did the air particles do as heat was applied to them, as the temperature went up? Well, the air particles obviously were moving faster. And your diagram then should have shown that the molecules were moving faster. Probably you drew longer arrows on these moving molecules. You then took a not closed system. It was open, but there was a 10-cent, a dime valve sitting on top of the bottle. And you took the bottle from cold water and you warmed it up with your hands. What happened to the dime? Well, after a little bit, the dime kind of jumped a little bit. What did the air particles do? Well, I think you probably recognize that they were coming out of the bottle. As they warmed up, again, they went faster. What did they do to move the dime? Well, they struck the dime with some force. They moved the dime. The kinetic energy of the molecules created a little motion in the dime. So when the gas particles absorb heat energy, I think it was pretty clear that they started moving faster, and many of them exited the bottle by moving the dime, by bumping the dime. The third one depends upon your understanding that marshmallows are mostly air. The matrix of the marshmallow is held up by air inside. When you reduce the pressure outside the marshmallow, what happened? The marshmallow got decidedly bigger, didn't it? Why? Well, the air in the marshmallow beforehand was moving around. A certain amount of energy depending on the temperature, and the marshmallow was being maintained in its size because the pressure inside and outside the marshmallow was the same. So when you decrease the pressure outside the marshmallow, then the molecules inside the marshmallow, the air molecules, continued to move, but there was less pressure outside to keep the marshmallow in its original volume. So the marshmallow expanded. Not because the marshmallow was expanding, but because the air was pushing out on the outer surface of the marshmallow. When the pressure changed, when you pushed in then, the air pressure outside increased. So what do gases do that creates pressure on their containers? Well, again, particles of the gases move. And outside pressure is reduced, the particles continue to move at the same speed, and they can push out on anything that happens to be containing them. Now we want to measure gas density next, just as we've measured solid and liquid density. So we ask the question, will changing the temperature change gas density? Will changing the volume change the gas density if the amount of gas stays the same? Is it important to keep that the same across our investigations? Will changing the pressure change the gas density if the amount of gas is constant? So say if we push in on a syringe and change the pressure, does that change the density? Well, I think you've realized from our investigation that the answer to all these questions is yes. And so what must we control to find a gas density, to compare gas densities across maybe 3 or 4 or 5 gases? Well, the answer is we have to control it all. We have to do it at constant temperature. We have to always get the mass of the same volume of gas, and we have to measure all of the gases at the same pressure. How's this done? Well, you can discuss this more with your instructor. But if we do everything at the same time in the same room, will the temperature stay constant by itself? Will the pressure stay constant by itself? And then can you control the volume by making certain that you're always using exactly the same volume in the syringe that is going to contain the gases?